Hi, I'm Jordan, and welcome to the first Panther Robotics Minute of the 2019 build season. On January 5th, Panther Robotics Team 1108 gathered with many other teams around the world to watch the robotics kickoff for 2019. I'm here with Isabel who is our 1108 Robotics President. Isabel, can you tell me a little bit about kickoff?
It was a lot of fun. So we went to one of our mentors' house, and then we ate some good food, had like breakfast, hung out, talked to all the other teams, not teams, but team members. And we also got to like meet their parents and stuff. And then at 9:30, I think, we all sat down in the living room and watched the game. We were all excited, and then we were like, oh man, what is this game? And then after that, we kind of cooled off a little, and we had a gift exchange, and it was fun.
That's awesome. Are you excited for our new game?
Yes, at first it looks kind of easy, and then you like get into it and read the rules and stuff, and then it's like, oh man, this is way harder.
All right, well, I'm really excited to see what comes out of this. During the first week of build season, Team 1108 gathered every night to prototype for their robot. Evan, can you tell me a little bit about what went down that first week?
Yeah, so mainly what happened is during brainstorming, what we mainly do is we get as many kids as we can here to all come up with different ideas for what they think would be the best for the robot. So what we do is we get pencil and paper, old school, gotta love it, and we have everybody draw what they think their dream robot is, what will be the best for the game. We go over the manual and they draw out what they think would be best to complete all the objectives in the game. We draw it all out, and then we vote on what do we think would work best, what would be most time efficient, what would work the fastest, and then we go through all of that and we vote on that, and then we make another list, cancel out everything that wasn't high up on the list, and then we cut it all out, we grab everything that was good, we make another list, and then we vote again. And then we go over all of that and we come up with the best scenarios on how it would fit on the robot, how would it work with the robot, and then we come up with another vote and which one will work best, which one will work most efficient, same as the first, both less options. Then on the third day, fortunately we had 2 days off because it was snow. So on the third day we took everybody that was here, not too many of us were here, it was still snowing, and we voted again on the final pieces of the robot that we thought would be good. We would prototype the day before, we would prototype everything that we needed, all the things, we would show them to the rest of our team, and then we would go back and we would vote on the things that we showed. And all the members got a vote on what they thought would work best for this year's objective. So, in the end, we came up with our idea, and as you can hear in the background, we're already getting started on this year's robot. So we've come up with our decision on what would work, and we're getting ready to build it.
Thank you so much, Evan. Good luck to the team. After the team did some prototyping and decided on their final robot design, we turned over to Sydney, who is our lead of build. Sydney, can you tell me a little bit about how you're starting off?
Well, so far this season, we've, as a team, decided that we're going with a modified crab drive, which means we're going to have some sort of pivot mechanism, which is actually what we're working on right now. This is the first stage of the robot, and we're working on mounting our new design of motor in the wheel, which is something we came up with on the off-season. And it's a mini sim with a planetary gear instead of a wheel. And that's how we decided to do Swerve this year, really cheap.
Can you tell me some of the other parts of your robot that are really important? Someone mentioned how you need to reach higher points in the game or pick up certain pieces.
Well, this year we've gone with a cascade elevator design, and that mounts on the front of the robot. while on the back of the robot, we're actually going to mount I believe an 18-inch roller. And then we have a special design that I don't know a whole lot about it right yet, but we call it the nail, and it's for picking up our discs really fast and really easily.
And what would be the end game for this robot?
The end game is kind of funny. We're actually just going to raise the robot up with 4 cylinders and drop it on its front end. Hopefully it lands. If not, I'm going to have to fix a lot this year.
Thank you, Sydney, so much. As usual, Team 1108 is focused on more than just building a robot. We have a member of our chairman's team here, Alyssa. Alyssa, can you tell me a little bit about what you're doing so far?
Right now, we just currently finished our executive summary, and we're working on reviewing our chairman's essay and working on our speech.
You guys spend a lot of time on these presentations, right? What do you do with them after you're done? What happens after that?
We use a lot of them in later on in the season, like after competition and everything. We use those presentations to present to a lot of our sponsors or schools or other important people for our team.
So does it take as long to make a chairman's presentation as it does to build the robot in these next 6 weeks?
It takes a lot longer than that. It's almost just as stressful as trying to build a robot. We work on it constantly, so while everyone's building the robot, we're kind of behind the scenes working on our speech and trying to pull people in for interviews for certain things, and yeah, we're just kind of the part of the team that no one sees.
Sounds like you're still very important, though. Thank you, Alyssa. I'm here with our lead build mentor, Bob. Bob, can you tell me about the progress we've made so far this season?
Well, we're really early in the season right now, so what we did on Sunday, today is Wednesday, what we did on Sunday is we did all of our prototyping to decide what we're going to build, and now we have a pretty good idea of which systems work and which systems might succeed, and now is the important part of the design phase. And this is always a difficult time because me and some of the kids are designing parts and in the computer, on the CAD, and trying to make everything work together so we can all sing together. But in the meantime, I have a lot of kids to keep busy, and they don't have as much for them to do. So we did sit around yesterday and we decided which sort of motors we would use for which systems and which air systems we would use for that. And so we outlined a lot of the things that need to go into the computer-aided design, and that means we'll be able to work on that and move forward. But in the meantime, we're getting ready to prototype some of the items again in wood this time, and we'll prototype them in wood. This is more of what we should really call it during the first week. We should call those proof of concept. The prototype is actually one that would be a stand-in for the real thing and actually be the right size and all that. So we'll be doing prototypes of the parts that exist, and then we'll be modifying them in the CAD and hopefully making them better.
So you do prototype or proof of idea more than once just to make sure it works right?
Right. The proof of concept ones that were done during the first week were more off scale, and they weren't necessarily planned to fit in the robot, where these are going to be actually built to the size and shape that we'd like them to go into the robot.
So do these prototypes still function after you've built your final design?
The plan. The plan is that if we wanted to, for instance, keep a practice spot around after, the prototype could be part of the practice spot, and it would be a functional copy of what will end up in the real robot, but it won't be as good.
So you mentioned CAD. CAD is the design program you guys use as a team, right?
We actually do our design on CAD. In general, we're using an old AutoCAD product because it's easy to teach, and as a school team, the modern computers are few and far between. But we have 2 CAD machines here, and I'm working at home some too.
So I did see a 3D printer around the shop earlier. Can you tell me about how you tie that into your build?
Oh yeah, well that is new for this year, and it is an excellent thing because it is a Prusa i3 Mark IIs, and it is a state-of-the-art 3D printer for this sort of use. We started printing a lot of parts that are our own design, so we'll be able to be more creative with what we build. And there's been a lot of teams had good success with 3D printed parts on their designs, even under structural loads, and we intend to be one of those teams.
Thank you. It sounds like we're getting really innovative here.
We want to teach kids about engineering, and about not just engineering, about how the real world works. And you know, you want to be able to build things in the real world. 3D printing is part of it now.
Thank you so much, and good luck with all your progress. I'm here with one of our lead programming mentors, Nelson. Nelson, can you tell me what to expect from our robot this year, programming-wise?
There's a lot of, as you saw at kickoff, there's a lot of vision targets. There's a lot of places to try to see, well, there's a lot of lack of vision for the drivers, so we're going to try to give as much camera support and support for the vision targets as we can, and also to be able to add as many movements that help the drivers when they're both in the sandstorm and during the regular time period.
So I know that over this summer you guys talked about trying out a new program instead of the one you usually use, or a new coding system. Can you tell me anything about that?
Well, there's always new stuff each year, and so we're always learning new stuff. We're still going to use LabVIEW this year, but there's a lot more opportunity to use all sorts. You don't use it just program in one programming language. Even the people that do it professionally, they know several. So we're going to try to utilize our knowledge in several different areas as much as we can. And to learn more. So.
Okay, thank you, Nelson. I'm Jordan. This was an episode of Panther Robotics Minute. Tune in next week for more.